Okay, so continuing from where we left off in the previous video on the hyperbolic trig functions, we found these two formulas. We derived it in that other video. This here's the power reduction formula for sinh squared and cos squared that we found in the previous video. And I've actually taken this is what we found in the previous video. What we found before was these formulas here in the middle, but what I did was just factor a half out of each of these. If you want to see the derivation for these formulas, I'll provide a link to that other video in the description. Now in this video, what I actually want to do is derive the half angle formulas for sinh, cos, and tan. So what I'm going to do for that to start is I'm just going to do a substitution, and we could change variables, but I'm not going to do it that way. I'm just going to substitute in for x. I'll substitute with x over 2. The variable name is not going to matter, so I'm just going to leave everything in x. So in order to do this, I can kind of just, wherever we have an x in these formulas, I can just plug in an x over 2. So we'll do this here and here, but we'll also do it here. And we'll also do it, I'm going to actually end up using this. We'll put it in here too. But then doing it this way, what's going to happen is the 2's are going to cancel everywhere over here. All this is going to cancel. And this will give us a way to express our half angles for sinh and cos in terms of just a single x. But now from here, what I want to do is I don't want expressions for sinh squared and cos squared. I want just sinh of x over 2 and cos of x over 2 to get our half angle formula. So what I can do is just take a square root on both sides everywhere for both these formulas. And essentially we can cancel square root with the square in both cases, but we need absolute value to be sure we've taken care of all the signs. So now we're getting close. We've got our formulas, but we've got these absolute value signs around. I'd like to get rid of these. So what I'm going to do, what I'll do first is let's just start with this one. Look at cos of x over 2. What I want to do actually is let's look at the graph of cos. So here's our small graph of cos of x. Not too worried about the specifics. And actually we should probably look at cos of x over 2, but they're so similar that I'm just going to look at cos of x. And what you notice about it is it's kind of like a parabola starting, but the lowest point is going to be at 1. So the important thing I want to notice is, first of all, it's always positive. And second of all, I mean, actually, if we look over here, this is greater than or equal to 1, because 1's the lowest point there. And of course, 1 is bigger than 0. And also we can look at the definition of cos over here and just notice because it's exponentials, both these terms are always positive and we're adding it together. So another way to see that this has to be greater than 0. So because cos of x is always greater than 0, and the same thing's true of cos of x over 2, I'm just going to remove the absolute value sign over here. And so on this, we don't have to worry about the signs. This is going to be our half angle formula for cos x over 2. Okay, next what we're going to do is let's look at this formula we have here for sinh of x over 2. We have our graph over here to the right. It kind of reminds me of, it's a lot like x cubed, where it's an odd function and it has the same kind of shape. But now this case is a little more complicated, but you'll notice it's always positive when x is greater than 0. It's always negative when x is less than 0. And again, x over 2 is not going to really change anything. It's just going to kind of skew the shape a little bit, but it's still going to be 0 when x is 0. And now again, we can look at our definition of sinh, and you can kind of see why we have negative values, because now we're subtracting something. So even though both these values are always positive, when this term is greater than the first term, of course, we're going to have negative values. And so you can kind of see that when we have negative x values, the second term becomes larger, and then the whole thing becomes negative. So we can kind of sum this up, and I'll do it actually for the x over 2 case. So we can say that sinh of x over 2 is going to be greater than or equal to 0 when x is greater than or equal to 0. And we can say sinh x over 2 is going to be less than 0 when x is less than 0. So to remove the absolute value on sinh of x over 2, we'll just do it in two cases. We'll look at it when x is greater than or equal to 0. And so in that case, we can just write this, I'll just make it clear with a plus, but we can just write it as square root of half cos x minus 1. But then for our case, when x is less than 0, then we're going to have sinh x over 2. This is going to be minus square root of this whole thing here. And now, of course, if you want, we can actually just come here and remove our absolute value on this here. And then doing that, we could just write this as a plus or minus here. The only reason I show it like this down here is you might run into a case where you actually want to know when is it plus or minus. It might not be enough to say just plus or minus. You may want the actual cases so you know when to use the positive value and when to use the negative value. Okay, now finally what I want to do is find a half angle formula for tan. And we'll use the definition of that, which is just sinh over cos. And we'll use our formulas that we just found earlier. So plugging these values in here. Now what I can do next is, what I'll do is I'll put these under one radical, and then the halves are going to cancel. So now I'll rewrite it and we'll bring over our plus or minus. And now the good thing about this is because we just found it previously, we know the different cases. We know that when x is greater than 0, we're going to use the positive, and when x is less than 0, we're going to use the minus. but for now I'm just going to leave it as plus or minus. So we'll put this under one radical, and we're going to have just cosh x minus 1 over cosh x plus 1. But now what I want to do is try to get some simplification on this, and what I'll do is we'll multiply numerator and denominator by the conjugate here. So I'll multiply by cosh x minus 1, and here we'll multiply by cosh x minus 1. Doing that, if I multiply this out, in the numerator we're going to have, this is going to be just cosh x minus 1 squared. And then here in the denominator, this is going to be difference of squares. So this is going to become cosh squared x minus 1. But now for this, we had an identity we found in the previous video. We found cosh squared x minus sinh squared x. This is just 1. Now if I rearrange this and add sinh squared on both sides and subtract 1, then we end up with cosh squared x minus 1 equals sinh squared x. So then this is what we have here in the denominator, so I can just take this and put this back into the integral. But now because we have the numerator and denominator squared, we can basically cancel everything out here. So I can rewrite this. We'll have our plus or minus in front. The numerator is going to become cosh x minus 1 absolute value. And then we have our sinh squared with this inside the radical, so this becomes absolute value sinh of x. But now you may remember on the previous board we said cosh of x is greater than or equal to 1. So then in the numerator it's always positive, so I can just remove absolute values here. And now here we're really close to our identity, but we've got a couple problems. I don't really want plus or minus, and I don't really want absolute value signs here. Well, what we can do is look at this as two cases again. We can look at it as when x is greater than or equal to 0. Then in that case, we actually want the positive in front, because that means going back, this was actually a positive sign here. So rewriting this, we end up with cosh x minus 1, sign removed. And then for sinh x, we determine that when x is greater than 0, sinh is always positive, so we just drop the absolute value. So we end up with just cosh x minus 1 over sinh x for our half angle formula when x is greater than 0. Next, let's see what happens when x is less than 0. So in this case, we determine we actually want the minus sign from our sinh. So this here is going to be minus. We'll have a minus in front, and we'll have cosh x minus 1. And for sinh x, we found that when x is less than 0, sinh is always negative. So inside the absolute value, we need to reverse the sign and write it as minus sinh x. But then minus is going to cancel with minus. And what we end up with is we actually have the same expression when x is greater than or equal to 0, or x is less than 0. So this is our identity for the half angle formula for tanh x over 2. One thing we need to keep in mind here is that when x is 0, sinh is 0. We don't want to divide by 0. So we'll put one restriction on this, that x is actually not equal to 0. Because we can kind of remove this over here, and we can use this as our formula. Now, one last thing we can do before we finish up is we can get an alternate form of this formula for the half angle for tanh just by doing a little bit different simplification on this. So we'll take it from where we left it at this point here and kind of rewrite it. So on the previous board, what we did is we just used the conjugate of the denominator. The only thing we're going to do different here is we're going to do the conjugate on the numerator. So I'm going to multiply here by cosh x plus 1 and do the same thing in the denominator. And doing this, it's going to be really similar to what we found before, so I'll go a little quicker here, because this here, when we multiply this out, this is again going to be cosh squared x minus 1, but we found that to be sinh squared x. And then here, this is going to be just cosh x plus 1 squared. But then again, we can cancel with the squares, and we can end up with this expression with absolute values. So we'll have absolute value of sinh here, and this is going to be just absolute value cosh x plus 1. But like we said earlier, I can just remove the absolute value sign here because cosh is always positive, and so cosh plus 1 is always positive. And now here with sinh, this is going to work exactly the same way it worked before. When x is 0, we just drop the absolute value sign, and we have a plus here, so we end up with sinh x over cosh x plus 1. But now again, when x is less than 0, we have a minus sign here, but when we remove the absolute value, we end up with a minus sign on the sinh, and those cancel, and we end up with the same expression here. And this here will just give us another identity for the half angle for tanh x over 2. And for this one, notice we don't have any restrictions. We don't have any divide by 0 problem because cosh is always positive. So we can just use this one interchangeably with this formula over here. Okay, so there you have it, half angle formulas for the hyperbolic trig functions. Thanks everyone for watching. Have a good day.